In these early days of virtual reality, we tend to think of it in a game or adventure environment, but virtual reality is also an important design tool. Here to show us some examples are Chris Allis, cyberspace missionary with Autodesk, and also Linda Jacobson, who is a computer writer and editor and specialist in the area of virtual reality, and who put together this handy-dandy guide to virtual reality from the people who make AI Expert magazine. Linda, let me ask you, there's so much hype about virtual reality and so much confusion about it. What is the state of the art right now? What is virtual reality? Where's the technology at?
It's coming out of the labs and into our laps, almost. Almost, Stewart. The technology that's called virtual reality has been around in the 40s and was mostly found in huge research institutions, mostly government-related, military-related, then moved into the giant educational institutions and is now moving down into the labs and offices of private businesses that are creating systems for people like doctors and architects and scientists to use to help them understand their data.
And so we have cyberspace missionaries like Chris at Autodesk. What's the philosophy at Autodesk? How are you using the concept of virtual reality?
Well, right now we're working on developing just the basic software tools that software applications developers will use to write these applications. Up until now, people have pretty much been writing their own software no matter where they are. But in order for an industry to get started and to be widespread, the people who don't have expertise in real-time simulation need to have tools that they can buy, pieces of code and so forth that they can put together, so they only need to work in their particular areas of expertise.
Now we have a fair amount of tools, hardware here. Why don't you go through this whole setup for us, Chris, and tell us what's here?
Okay, well, first of all, we're running this software, these simulations on PCs, a 386 here, a 486 here. We have a variety of I/O devices. Remember, VR is not about just exotic I/O devices. You can run it with a mouse, regular old Microsoft mouse, up to the more exotic sorts of input devices. This is Data Glove. This is one of the two items that the public seems to mostly associate with VR.
The goggles.
The other are the goggles, the head-mounted display. You have the computer tracks this as you wear it. You have two small TV sets inside that show you what the computer is displaying, and it really allows you to be in the middle of the computer graphics. It allows the graphics to surround you and gives you a real feeling of being there.
All right, let's start out with what you have over there on the right. What's on that monitor, Chris?
Okay, this is actually a something that we started working on when we wanted to get away from the feeling of VR having to have goggles and gloves. So I'm controlling this display just with a mouse and eventually with a keyboard. But it's still, the display is still, I'm looking up, I'm looking down, and looking left and right and so forth. So it's still governed from the viewpoint of somebody who's wearing a head-mounted display.
So you are kind of moving around in that environment, controlling it with a mouse.
I have balls here that are suspended in space. Now they're attached. I can increase gravity, decrease gravity, and so forth. I can.
So then you're not pulling that. You're changing the physical parameters of that environment.
I'm changing the physical. Yes.
Yeah.
And I can even let me move in here a little bit, get a little closer, and I can even maybe grab one of these and make it heavy. And then if I detach one end, you get the kind of interaction, and now I can add energy to the system. And you get the kinds of movement that you might expect. Or if I reach down here perhaps and grab one of these, let me see. And I can move up. And
so you can sort of play in that world.
Right. This isn't, say, a complete application. This is merely a demo that one of the programmers worked out to test out physics, to test out.
Well, you have another one that maybe people can relate to, which is a billiards simulation.
So let me bring that up. This is when you add a little more complicated interactions to the simulation. Wait for it to come up here, and
Okay.
again, you've got
Now you're controlling where you are with the mouse.
with the mouse, and this is actually another kind of view. This is deciding that what I'm really interested in is the cue ball, and so no matter where I look, I'm going to be rotating around the cue ball.
Uh-huh.
And give that a little shot here.
And so here you've got to be simulating the
can
real
actually-
physics of this environment.
Ooh, almost in.
Mm-hmm.
If I just move this over here, check it out, maybe with an overhead.
All right, Chris, what's going on over here on the left-hand monitor?
Okay, well actually what you're seeing here is the same simulation that we were seeing earlier on the other computer with different graphics hardware.
So the
that
ball's
it-
hanging from the two arches.
Right.
Uh-huh.
This looks different, but it's the same software and so forth. It's being controlled this time by the head-mounted display, so that as this moves, the picture
Okay.
moves.
Excuse me, Chris.
Yes.
You have a volunteer.
You'd like to try it.
Yeah, I
Okay,
would.
so Linda will go into the
All
world
right.
of virtual reality.
I'm in it.
All right.
And we're seeing
Where
then
am I?
on this computer monitor
Ah,
what
there it
she
is.
is seeing.
There
Right.
it is.
And so she tilts her head left,
And look
right,
left.
up,
Actually, I
down,
can
etc.
move her in a little closer here,
Whoa.
and she actually can get much more of a feel of just how large this model is.
Uh-huh.
And as I change, say,
Now what are you changing,
light-
Chris?
I'm changing gravity there so that the pull on these tetras is slightly
Whoa.
smaller. And
So Linda,
actually, if
your
you-
world is changing as he's adjusting this.
I'm
Yeah.
getting lighter and lighter, Stewart.
So if you just sight in on one of those, whoa, here, just here, steady down, and
Okay.
let's grab one.
Okay.
Uh,
How about that
So
one?
you're going to make that object heavy.
yeah, and it settles down a little more.
And so
you
Linda,
can see that actually more if we increase gravity
Yeah.
here.
Whoa.
whoops, so Linda has to bring her head down to keep up with you.
Right. And so that adds in then that
Right.
additional spatial sense.
Okay, now can we
that one
add
might
the
have.
glove element now? What does this do?
Okay, well actually,
glove.
in order to add the glove, I'm going to move over to another demo. This is actually older software
Uh-huh.
than what we're
So not the
been
latest stuff,
working
but
with.
it'll
Not the
Ready?
latest
show
stuff,
how the glove
but it
works in-
provides a
in
good
fundamentals,
example of
okay.
just how glove interaction might happen. So put this
Okay.
on, one finger per, standard issue.
Okay.
This is
Okay.
good. That's good, good, good. Okay.
So now basically this glove is the input device and the goggles are the output
Are the
device
output
for
device.
Linda.
Right.
So she can determine now what she's going to look at by pointing.
By pointing where she wants to move within the model. So at this point, if you make a fist,
So you're going to
just sort of-
calibrate the glove right now.
Yeah,
So
tell
it knows what a fist is and what an
Got it.
open hand
right,
is.
and it's
And now we can
sort of
see
letting you
her
know.
hand on the screen in this
Right.
environment. And Linda,
So
tell us, what
actually-
are you doing now? What's your experience?
Well, I'm definitely in cyberspace, and you can see I'm moving my hand. You can see my hand in cyberspace also moving.
So now
Let
if
me-
you point someplace where you want to go,
Let's go there.
and
Let's
you'll
go
end
there.
up flying.
Let's go there.
And you just
Whoa!
follow.
I just flew right through a
You follow your
column
hand.
there. Okay, let's go in the other direction. Let's go up. Can I go up?
Yes.
So you're in charge of this
Let's go
world,
down.
Linda. Okay,
Right.
we're going to have to get
Okay.
out of this world, guys, because we're out of
Okay.
time.
Whoa!
Sorry,
Close
sorry.
encounter with a chair
Bye.
there. All right.
Chris, Linda, thank you very much.